Good morning, students. The previous class we have learned the vectors and the various types of vectors. In this session we are going to discuss about some of the operations on vectors. So vector can be added, subtracted, multiplied as we do in the case of real numbers. So here we are going to see the operations on vectors and how they multiply, added or subtracted. And let's see multiplication of vectors. But when a vector is multiplied by a real number with real number, what happens to vector? For example, a vector A, this is a vector A, and this vector A is multiplied with a real number. If it is multiplied with a real number n, then the vector will be n into A times. Okay, that means n times of A. Okay, and what is the magnitude of the real number n, and that much times the vector is multiplied. Okay, for example, this A is multiplied 2, then A, this is the vector A, is multiplied 2, and the vector becomes 2A. That means 2A. And when a vector is multiplied with a scalar quantity, what happens when a vector is multiplied with a scalar quantity? For example, there is a vector A, and this vector A is multiplied with a scalar quantity S, and the magnitude of that vector becomes S into A. Okay, and S can be the vector, the scalar quantity. The direction of the vector does not change at all. They retain its previous direction and only the magnitude will change. When a vector is multiplied with the scalar quantities, lot of examples. For example, force, as we know, is a vector quantity. Okay, and force is m into A, where A is the acceleration is the vector quantity, where m, mass, is a scalar quantity. It has no direction, only magnitude, but acceleration has both direction and magnitude. So likewise, for again, momentum is a vector quantity. So what is the momentum? Momentum is m into v, that is mass into velocity, where mass is a scalar quantity and velocity is a vector quantity which has both direction and magnitude. Next we are going to see the addition of vectors. So when two vectors are added, then a resultant vector is obtained. Then what do you mean by a resultant vector? A resultant vector is a vector is obtained when two vectors or more vectors are being added up. A simple vector is produced whose effect is same. That means the magnitude and direction remain the same. It does not change at all. Okay, and such a vector is known as the resultant vector. For example, a vector A is added with the vector B, then a resultant vector may be obtained as C. Okay, and this vector C has both the same direction and magnitude. So when these two vectors are added, there are We cannot simply add them like we are doing the scalar quantities. And they have to, while adding them, we need to follow some rules, okay? And we need to follow some laws. And now we are going to see some of the laws or rules that are associated when two or more vectors are being added up. And let us see the first. The first is tail head method. And this in a tail head method, for example, if we here consider two vectors are added. A vector is A. This is vector A and this is vector B. Two vectors are here. And now these two vectors we need to add them together. Okay? How we can add them? What do you mean by tail head method? So let us take the first method, the vector B. Okay? And take this vector B as it is. And now bring this vector A. Okay? Move the vector A parallelly towards the B. That means the direction we need to change this vector A without changing its direction. Okay? So we parallelly move them to the head of the vector B in such a way that the tail of the head vector A coincides with the head of the vector B, like this. Okay? And see that, make sure that there is no change in the direction of these vectors when they move and before, after moving and before moving. And now, as we move them, then what happens? Take this vector B as P, Q, and this is what Q, R. Okay. Now add the join the tail of the vector B and the head of the vector A. Now this forms a triangle. Okay, and this forms a triangle PQR. Okay, and the resultant vector will be the sum of the vector A and B. And what is that? This is PQ plus QR will be the resultant vector. That is, the resultant vector can be written as C. Okay, or we can say, we can write as P R. PR will be the resultant vector. So we can write, and this will be then C. Okay. So A plus B is equal to P Q plus Q R, that is equal to P R, that is equal to the resultant vector C. And this is how we add two vectors in tail head method. Next method is parallelogram law of vector addition. Here also we consider. Next is parallelogram law of vector addition. In this method, consider two vectors A and another vector B here. Now we need to add these two vectors together by this method. And as I said before, okay, first of all, take the vector A and tail of the vector A without changing its direction. So now this is vector B. Okay, this take as P, Q, and this is R. To make the adjacent sides of PQ and PR. Okay. So what will be there? Take this point. Adjacent sides of PR is Q here. Opposite sides. Okay. PR, QS. So that both are parallel with each other. Then PQ and RS, they are parallel with each other. Now this forms a parallelogram. And the diagonal of this parallelogram, okay, that means PS. Now this PS gives, if we take this PQ and PR. Since PQ is similar to RS, so we may write PR plus RS is equal to PS. That means this become a side of a third side of a triangle PRS. Okay, so it is same as that of the triangle law of vector addition. So that means here we can write PR plus RS, that is equal to PS. PQ, okay, PQS forms another triangle. Okay, that means PQ plus QS, or we can write PQ plus QS is equal to PS. That means vector A plus this side and this side extends in the vector B. Okay, and also gives the resultant vector of this triangle, second triangle PQS. So that means when here vector A, B is added together, okay, so we can write A plus B is equal to PS. Okay, so that is the resultant vector here, or the resultant vector C, and this is the vector parallelogram law of vector addition. And the parallelogram law of vector addition states that if two vectors acting simultaneously along the same at a point can be represented as the two adjacent sides of a parallelogram, the resultant vector is completely the diagonal of the parallelogram formed here. Then these are the two methods of vector addition, triangle of vector addition, and it is from these two methods it is evident that the parallelogram law of addition resembles the law of triangle of vectors. So the parallelogram law of vector addition is same as that the triangle law of vector addition. So that means from the parallelogram law of vector addition we can retain the parallelogram triangle law of vector addition. For example, in this case, if we have seen that this A plus B, okay, that is PS. So we have written here A plus B is equal to PQ plus PR is equal to PS. Okay, A plus B is equal to PS. So in this case, this is a parallelogram, the opposite side, okay, the same sides are parallel with each other. That means PR is equal to QS. So therefore we can write A plus B. Okay, this is also same B. If this vector is B, then this is also same. It has the diagonal. Sorry, the side PQ has the same magnitude and direction. So we can write A plus B, that is equal to PQ. Now vector addition is commutative. For example, if we take the same example, A, B, P, Q, R, S. S is the resultant vector. So A plus B, that is equal to, for example, let's write A. A is what? A plus B is equal to B plus A. That is what commutative property says. Here A plus B is equal to A is equal to P Q plus then B is P R, that is equal to A plus B. Then B plus S is B is equal to P R plus P Q, and both these PS. So both gives the resultant vector diagonal PS. So that this satisfies. Okay, PQ plus PR is equal to the same. The direction and magnitude does not change. Okay, so it is a vector addition is commutative. Ordinal law of vector addition says when a number of vectors are added together, okay, more than 2, then there also we can add them together and can find the resultant vector. For example, a number of vectors, okay, A B, C, D. Okay, a number of vectors are there. So how we can add them together? And first, as I said, okay, we move this, take the vector A, okay, and vector A, and this is vector A without changing the direction. And now we use the head to tail method. And now move the vector B parallelly to the A without changing its direction, and make sure that the tail of the vector B coincides with the vector A. So now this is the vector B. Now the resultant vector, when they add them together, what will be the resultant vector? For example, this is K, this is L, this is M. Now the resultant vector can be written A plus B is equal to KL plus LM. That is, if you join these two lines, this will be the, that means KL plus LM, that is equal to KM will be the resultant vector. Okay, now that is equal to K. Now the third vector, that is C, and bring the C, okay, move parallelly towards this one, okay, parallelly towards the plane, and bring its tail to the head of the vector B. Okay, how this way? That is vector C. And now add them together. A plus B plus C. Now how we can write? A plus B plus C. That is equal to A plus B plus C. Okay, that means A plus B is equal to what? K M plus what is that? M. This is N. That is plus M into N. So that is equal to, if you join this line, okay, then what will see? K M will be the resultant vector when they are added together. Okay, that means K M plus M, and that is K. Now the fourth vector D. Now the same way, bring the fourth vector to the tail here, and without changing its direction, that is D, and now join the line M and O. Now what will be the, now A plus B plus C plus D, that is equal to A plus B plus C is K. That means Km plus NO. Okay, that will be KO will be the resultant vector. So A plus B plus C plus D is equal to KO. That is Km plus NO. That is KO will be the resultant vector when they are together. And at any number of vectors can be added by this method together, and can find the resultant vector. And this law is known as the polygon law of vector addition. And from also this example we can see that, and this vector addition is also associative. Okay, it obeys the associative property of addition. Okay, so that means the associative property, we can say A plus B plus C is equal to A plus B plus C. Okay, so it obeys the associative